In this video, we will talk about vectors and scalar quantities and what and their differences. And this will be essential for your study in kinematics, especially first and second dimension, and especially for those who are taking physics courses in the allied health and physics in the life sciences, just like me. So first, let us differentiate what is the difference between a vector and a scalar quantity. I will adjust pen. So what is the difference between a scalar quantity and a vector quantity? So a scalar quantity usually talks about the measurement of your magnitude. So what is this magnitude? It typically refers to the size, or let's say the length, the mass, or speed, etc., etc. And one common trend among these measurements is that it has no direction, meaning that scalar quantities are just values or measurements of an object without a direction. So let's say this is length. Let's say you are measuring like a ruler or something. It's not pointing at any direction. It's just the length of a something, diba? It's just a length. So, let's say kunwari ito, speed. Itong speed. Speed, let's say you are measuring speed. You are just calculating how fast it is going, diba? So, let's say 30 kilometers. So, that's per hour rather. So, that's a scalar quantity because you're just measuring without any direction. But, if you add like a direction on there, let's say this object is moving 30 kilometers per hour in the east direction. Now that object is not anymore a scalar quantity, but now what you call a vector quantity. So with that, we know that vector quantities are measurements of magnitude and directionality. Okay, so vector quantities are just measurements of magnitude with direction. And an example of that is this one. It's what we call your velocity. An example of that is velocity. Sorry. Another one is what you call your weight. So maybe some of you may get confused of the difference between mass and weight. So this will be tackled on later on, especially in the topic of dynamics and equilibrium. But for now, let's establish the fact that mass is not equal to weight due to the influence of gravity on the other. Okay, so gravity is a vector quantity because later. Let us establish the fact that mass and weight are not equal because the other one, which is your weight, is being affected by gravity. Moreover on that, but let me give you an example on why it is a vector quantity. So let's say you're here on Earth and you weigh around 70 kilograms. So pagdating mo sa moon, you may get lighter because like mas baba yung influence ng gravity sa moon. So you may weigh there around mga 40 kilograms. Or let's say sa Mars, you may weigh even lighter because mahina lang influence ng gravity. So you may weigh like 30 kilograms like that. So you see nagbabago kada planet pa. So the fact that it's changing makes it inconsistent. So since ang pull ng gravity is downwards, diba? So you're anyway, let's not get too indulged on that because it will be for another topic, which is your equilibrium and dynamics. But for now, let's establish the fact that mass and weight are not equal due to the effect of gravity. So, okay. Another example of this: velocity, weight, and the force rather, and force. Because let's say this is your object, diba? And you apply a force this way, and that force is expressed in newtons, diba? So you are pushing this object towards this direction, and it has a direction. So meaning it is a vector quantity. Okay. So I hope that this that established the difference between the two. So the main difference lang is this one is with direction. And excuse me. So typically, your scalar quantities are expressed in uh, the symbol or the symbol with an enclosed in a enclosed into absolute value bars. So it's like that. And your vectors typically are symbolized by your arrow and the symbol with an arrow on top. So that's typically how you describe your scalar and vector quantities. So that's the difference between the two. So for practice, let us have this example. Ano ba maganda? So let us answer this one. This one is describing force. So meaning it's a vector quantity because it's applying 165 of force of Newton worth of force to the right direction. So the fact that it already has a direction there implies that it's a vector. The second one is 65 meters per second. So it doesn't indicate any direction, so that's scalar. And similar with number 3, it's also scalar. And fun fact, this is the speed of light. It's irrelevant, but I just wanna say that. And number 4 is 75 newtons, and it says it's the weight. It's the weight of an object, so meaning it's a vector quantity. Moving on from that, let us discuss about vectors. So vectors are typically expressed, usually visualized, no, not really expressed, usually visualized through your Cartesian plane system. Sorry. Ba't kaya tabingi? Ayan. Vectors are typically expressed in your Cartesian plane system, and whenever we draw vectors, usually the first vector usually starts at the origin. And so let's say you have vector here, vector A, moving at 30 meters per second at 30 degrees north of west, or north of east na lang. So sabi, your vector is moving at 30 degrees north of east. So this is your east, this is your north, diba? So north of east. So this is your east, taas daw ng east, which is north of east, taas ng east. So like this. So your vector is expected to go this way. And it's 30 degrees. 30 degrees. So let's say this is your vector. It's moving at 30 meters per second, and the angle between them is 30 degrees. So that's typically how you express your vectors. Sorry. And next one, uh, since your vector is moving at a certain angle, it is expected that it will move towards the x and y direction. So let's say this is your projectile. So let's visualize. uh, sorry. Wait lang. Anyways, so let's say this is your projectile and it is moving 30 meters per second at 30 degrees north of east. So it's like this, moving like this. So from this, we can imply that this object is moving along the x-axis, which is your east, and it's moving along the north one, which is your uh, y-axis. So let's say na walang x-axis movement. So meaning your object will just go towards the north. And if it doesn't have any y-axis movement, it will just go towards the east. So the fact that it's moving towards this way means that it not only has your x movement but also y movement. Okay? So from that, how do we compute for the movement of that projectile along the x-axis and along the y-axis? So let's draw this one. So how do we draw this? How do we determine it? So first thing that we can do is to draw a straight line from the tip of that vector towards the x-axis. So I hope you understand the terminologies revolving around Cartesian planes. If you still haven't, you may watch the previous video. I think it's titled The Cartesian Plane System. So anyways, you may watch that if you don't understand the terminologies being stated here. So anyways, uh, first thing that you need to do is to draw a vertical line spanning from the tip of that vector towards the x-axis. So why are we doing this? Because that vertical line corresponds to the height, uh, the height, the height that that projectile is reaching. So as it moves here, diba, it reaches the height, this height. So it corresponds, I'm sorry, tumunod na. So it corresponds to the height or the y component rather, or the height being taken the projectile as it moves along this path, diba? So, yon. And one thing we can see there is that this line is, one thing we can also think about that is that this line is parallel to the y-axis. So meaning, whatever the height of this line is also the height that the projectile is achieving in the y-axis. So we can call this your y component. And similarly, if you have this projectile, as we said, it's moving along the x and y axis, this movement here is, we can consider that as still movement along the x-axis since it stopped here, diba? At the tip of the vector. So here, so this from here, the starting origin to here, will be the movement of that vector from origin to here. So this span here is the projectile's movement on the x-axis. So we can call this your x component. Okay, so with that, we just have to remember three the three trigonometric ratios, or your SOHCAHTOA, to be able to identify the values of the x component and the y component. Okay? So let's say let's recall what the SOHCAHTOA is. So your sine is equal to the opposite over hypotenuse. Your tan a cosine is equal to the adjacent over the hypotenuse, and your TOA is equal to your opposite over adjacent. Okay? Now, in order for us to get the x and y components, we need to take a look at the angle between the vector and the x component, and between the vector and the x-axis. So this is the x-axis and this is your angle. So what is the angle between them? It's 30 degrees. And one thing that we should know is that your SOHCAHTOA is based on the angle. Okay? It's based on the angle of your vector. Okay? So let's say if you're finding the y component of your vector, you need to take a look at this. Alin sa trigonometric ratios na to ang applicable so that I can find the y component given na meron akong angle and meron din akong given na value ng hypotenuse, which is yung ating vector. Also, always remember that this setup will form you a right triangle. That's why we used SOHCAHTOA in the first place, because it's a right triangle. And that right triangle, in that right triangle, your hypotenuse will always be the vector. Okay? The hypotenuse will always be the scalar quantity or the magnitude of that vector. Okay? Ayan. Sorry, sinisipon ako. So, anyways, let's say you have the x component, a y component. You want to find the y component of the vector given na meron kang value ng hypotenuse mo, which is your vector, and your angle between the x and the vector, which is 30 degrees. So, you have your y component, you have your hypotenuse, and you have your angle. Your y component here is directly opposite of the angle. So this one is actually the opposite of the angle. Now you have the opposite, you have the hypotenuse, and you have the angle. So what can we use? Syempre, this one. We can use that one to determine the value of your y component. So, sabi rito, ang sine ng angle, which is 45 degrees, 30 degrees pala, sorry. 30 degrees is equal to the opposite side, which is your y component, over your hypotenuse, which is 30 meters per second. So, with basic cross multiplication, we can isolate this one. Because we're trying to look for that one, diba? So, we can isolate that one like this. So, we will get y comp is equal to 30 meters sine ng 30. So, with that, we can see that in order for us pala to get the y component, we only have to multiply the value of the vector. So, meaning the value of the vector, the magnitude of the vector, which in this case is 30, represented by a. So, that's a. And the sine of the given angle. Diba? In this case is 30, diba? So, sine of the given angle. So, sabi nila, in order for us pala to get the y component of your angle, y component of your vector, you can get that by getting the scalar quantity and multiplying it to the sine of the angle. Now, let's say you need to find the x component. This one naman. So, this one, take a look at the angle. Where is the thing we need to find? It's directly adjacent. Magkatabi sila. So, since magkatabi sila, this is actually now your adjacent side. Okay, adjacent side to the angle. And now, since we need to find this, and you have your hypotenuse, you have your angle and your x component or your adjacent side, what what trigonometric ratio can we use? Siyempre ito. Kasi meron tayong adjacent. Ay, mali. Adjacent. Diba? And we have the hypotenuse. And we have the angle. So, ayun. We can use cosine pala actually to get the x component. So, with that, sabi rito, the cosine of your 30 degrees is equal to the x component. It's the adjacent side over the hypotenuse, which is 30 meters per second. So, by cross multiplying, you will get x component is equal to 30 meters per second cosine ng 30 degrees. So, in other words, we just need to multiply the value of your vector. Okay, you just need to multiply the value of your vector A to the cosine of your angle. Okay? Sorry, kanina pa ako okay na okay. So, ayun pala, pwede pala natin to gamitin yung general formulas na to in order for us to find the x component of your x component of your vector. Ayan. So, I'm gonna leave it up to you to answer this vector question. I want you to find the x and y components of that vector using this formula. Okay? So it will just be like let's say you're finding for the ay, so that's the y component of your x, so that's just 30 meters per second sine yung angle natin, 30 degrees. And similar for the x-axis, just 30 meters per second cosine 30. And the answer, I will leave you to answer that question, and I will post the answer in the comments. Okay? Na ba okay na okay? Okay. So now that's the mathematical way to resolve your vector into its x and y components. Yan. Delete na natin. So next one, we have to talk about vectors involving two vectors. When we talk about vectors, two vectors, it is usually just a combination of two vectors. Let's say this is 30 newtons, 15 newtons, 30 degrees from the x-axis, and this is 45 degrees from the x-axis. So when we're talking about vectors and vector addition, it is usually just, as the word implies, addition. Vector addition. It is usually just the combination of the two vectors. So, as I said earlier, whenever we start drawing our first vector, we need to start at the origin. So, your first vector, let's say this is your first vector and this is your second vector. Sabi, 30 degrees. And it's 30 newtons. Okay? So, that's the first vector. So, for the second vector naman, just have to draw. You don't have to start, or you don't want to start at the origin again, because the origin belongs already to the first vector. So the thing that you can do is just draw another Cartesian plane on the tip of the first vector. So ayan, we're gonna draw a Cartesian plane, and sabi rito is 45 degrees from the x-axis. So it's around here, like that, and it's 45 degrees. Ay, mali. Sorry, 45 degrees and 50 newtons. So with that, how do we add these two vectors together? So how do we consolidate the two vectors to find like one whole vector that expresses these two vectors? So one thing that we can do, this thing that we did actually is what you call your head to tail method. So this is one way of visualizing vectors. So after that, you need to draw something, a line starting from the tip of the second vector towards the, medyo pangit siya, no? Sorry. Oh, ganyan dahil. Ayusin lang natin yung ayusin lang natin yung paka-drawing ko ng 45 degrees. Ayan. This is 50 newtons, 45 degrees. So starting from here, you need to draw a line. And that line is the vector that tells you the overall effects of your first and second vector. And that resulting vector is what you call your resultant vector, usually expressed like that. So that's one way to determine what the resultant vector is for two vector, or that's one way of determining vector, your resultant vector from vector addition. So that's gonna end with the lesson for now, because in the next lesson we will try to solve different problems regarding vector addition and x and y components of a vector. So I'll leave this part to you as an assignment. So do not do this. We'll do this on the second video, but I want you to do this to test. Okay, I want you to compute for the x and y components of the following vectors. So yeah, that's it. Thank you.